One of the things that I like to get out of the way early on is the discussion about the words and or as used in mathematics. Because it's not exactly the same as it used outside of mathematics. Suppose we have statements. Something like today is Monday, or the cat is Orange Tabby, or I didn't go to the movies yesterday. So these are statements. We use the words and or to combine several statements to create something we call a compound statement. First of all, this is a huge difference. In mathematics, the words and or combine only yes or no questions. True or false, yes or no. Let's see an example. Suppose there is a student and they have a math class and it's exam day today. And the math teacher asks the student, did you bring a pen or a pencil? For this question, what does a yes mean and what does a no mean? So if a student has both, the answer is obviously yes. What if the student only has a pen? Well, the teacher asks, did you bring a pen or a pencil? Well, the answer is yes. And if a student has only a pencil, the answer is still yes. And the student says no. The only way that is possible if the student has neither of those. Okay, so suppose this student next has an art class. Today they're gonna do drawing, so it is very important that students have both pens and pencils. And so the art teacher asks the student, did you bring a pen and a pencil? Now what does a yes and what does a no mean? The question of pen and a pencil. A yes means that the student has both, and a no means everything else. Only a pencil, only a pen, or neither. That is similar to how the words and or operate when combining statements. We use something called truth tables. So a truth table looks like this. Suppose we have statements A and B. So for A or B, that is like the math teacher. When we are asked, did you bring a pen or a pencil? If just one of the two statements is true, the or compound statement is true. And so the only way an or statement can be false is when both statements making up the compound statement are false. That's the only way. It looks like it is easier for a statement to be true if it's an or statement, right? Okay. A and B, that's pen and pencil question coming from the art teacher. How can we get a yes? That would be the same as how can A and B be true? And so the only way A and B can be true is if both A and B are true. If just one of them is false, then the end statement is false. So it is easier for an end statement to be false than it is to be true. It kind of makes sense. If you look at it, if both statements are true, then or and, they agree. And same if both statements are false, then both compound statements are false. The difference is when one is true and the other one is false. Then the or statement is true, but the and statement is false. That makes for kind of strange true sentences. Check this one out. So here is a strange but true statement. I am the Queen of England, or 7 is an odd number. This compound statement is actually true, not because I am the Queen of England, but because 7 is indeed an odd number. And why do I like to have this conversation early on? In my experience, the first symptom of not understanding the words and or is not being able to handle this symbol. This reads less than or equal. Is short for 5 is less than 9 or 5 is equal to 9. That is a true statement because 5 is less than 9, and in case of an or statement, one true statement is enough. Now what about this one? This says 9 is less than or equal to 9, so that's true too, because now the second part too is true. And finally, this is going to be false, because 12 is not less than 9, and 12 is not equal to 9 either. So this is a false. This is a true statement, this is a true statement, this is a false statement. So because of these inequality symbols, it's good to know where we stand with the usage of the words and or, but it will come up. It will be important in other areas in mathematics as well. Thank you for watching. A true